Going down. Hello and welcome back to Shane's DIY. Today's episode I think is pretty cool. It's something I've been working on for a while now. There's a Radiomaster's got their R series receivers. As I mentioned in the previous video, I did one video with this receiver a little bit ago for voltage telemetry, and I showed how to actually add pack voltage telemetry to this receiver. So it's actually pretty cool for only $12 or $11 plus the shipping. That's pretty neat. The problem with it is a lot of people report that they've had disconnections and issues with disconnecting from the receiver, crashing their planes. I'm skeptical of that. You know, as a lot of us are, we crash our planes. We like to blame it on anything but our skills. So I was keeping an open mind on this thing, and I wanted to check it. For 12 bucks, I picked up a couple of these, and I've been doing some testing. One thing that a lot of people were asking for, and I mentioned I was getting ready to do this, and people seem to be pretty excited about it. I wanted to do some range testing on this receiver, but I don't want to do the typical range testing. Most of these people they'll just do range testing on the ground, and it's not really representative of flying. I came up with, I think, a creative way to check the range on this thing. Will be, I consider, very scientific with a lot of detail. This video might get a little bit long, so apologize for that if it does, but I think there'll be some interesting information if you're willing to sit through the video and analyze the data with me. It actually got a little trickier than I thought it was going to be. It took me 3 tries to actually get a system that would work properly with this. I won't bore you with too many of the details of the first 2 tries, but I will show kind of the results of what happened. But the basics of the test is I have a drone. This is an SJRC F22S 4K Pro. It has really long range, but as most of these drones, these camera drones, the transmitter gives you distances and altitudes, and you've got that telemetry right on your screen. We can focus on that. I'm going to attach that receiver to my drone with the other parts that go with it, just to give me a connection to my. I'm using my Radiomaster TX16S with this. This is actually the 3rd iteration of my setup to try to get it to work. This was the final test where I actually had the antennas in parallel to check how that affected the range. First one ended poorly. I did manage to get it out about 760 feet or so. Never lost connection. I couldn't get the altitude I wanted. I'll show you what my first idea was, and it was kind of a disaster because the day I tried to go out and do it, it was windy. And I had this big thing hanging off the bottom of it, which kind of made a big sail out of it, and it didn't work very well. So anyway, I'll just do a brief video on footage on that one and how it ended. Second iteration, I might show a little bit on that, but I essentially had these same components mounted on top, but it turns out the GPS is right here, and I had the R88 right there with the antenna, one of the antennas right over the top of it. And when I had it in that orientation, I could never get GPS locked, so the drone would never take off. So, test number 2 was a failure as well. This one is iteration number 3, and I've got these mounted to the side. I can still land and take off with it on the ground. Nothing was interfering with the optical flow sensor, and obviously no big things hanging off of it that would make it catch the wind. Let me jump over here. This is the receiver I'm talking about. On Radiomaster, it's still for sale for $11, $10.99. If you trust it, it's kind of hard to beat that price for an 8-channel receiver with voltage telemetry. Not advertised voltage telemetry. You'll have to go back and look at my other video on voltage telemetry, but there's a pin for it, but they don't advertise it, they don't show it, and it's a little bit of a trick to get a signal out of it because they don't give you the plug for it. I'm pretty excited so far. Bit of a spoiler, I got very good results on this test, but you'll have to kind of go through. I was very methodical. Let me show you my spreadsheet on how I plan on doing this testing. All right, so here's my spreadsheet. So I've got the R88 V2. I've got this bound as FrSky X D16. This receiver will bind as D8, which you do FrSky D8, and it'll also do the Futaba SFHSS protocol. That protocol doesn't have any telemetry, doesn't have RSSI or anything, so I'm not using that one. This one gives me the most information. Another thing that I am doing on here, if you see the RX volts, I've got this first test set up for 7 volts. I have a little 2S battery on here, a little lightweight one. That's, instead of feeding an ESC, I'm actually feeding this little variable power supply. So I feed the 2S into that, and I can adjust the voltage, you know, basically simulating a BEC for your receiver. And I've got that set for 7 volts. The R88 has a voltage range, if you look on the side of it, of 4.5 to 8.4 volts. Part of my test is to see if your BEC voltage that you're feeding the receiver between 5 volts and 7 volts makes any difference on how far it transmits or the signal strength. So we're going to do that during the test. But you can see my first test here, I've got, if you look at the screen, I got 7 volts here is where I've set it the first one. We are looking at the transmitter voltage. That'll be on the real time. I just kind of guesstimated 8 volts. I'm sure it changes over time as I'm doing the test, but it's going to be overlaid on the screen, so you'll see that. I also did the receiver fine tune, which you have to do with the FrSky protocol. In my case, the numbers that I got was a -50 and a +76, which came out to a +13 value for my fine tune. Initial test is with the receiver antenna perpendicular. So you can see right here, this is left from my final test. The first test, I had one antenna come off the side and the other one coming out the back. So I wanted to compare that to see how that works, perpendicular and then parallel, and see how it compared when you at range. So what the test is going to do is I'm going to get it up to 100 feet, and then I'm going to go out and go at 0 feet, and then every 200 feet until I lose connection. And I'm going to get the RSSI values for each of those steps. And if you can see, I'm also going to check with my transmitter. Okay, so I've got my Radiomaster TX16S, and as I go out to those different ranges, I'm going to orient the antenna. Initially, it's going to go off to the right, and then as I go out at different ranges, I'm going to orient it up, and then also straight out, like a lot of people want to do, is point it at the plane and see how that affects the RSSI signal. And you're going to see as I get further into the test, I tried left versus right, and actually had different results. So we'll get into that, and I'll show you how that turned out as I populate this spreadsheet, and you'll see that. And we'll populate this spreadsheet, and then at the end we'll kind of go over the data that we collected during all the testing. Also, as you can see in the spreadsheet, I'm going to fly straight out and then stop every 200 feet, and then we're going to record the values with the drone pointing away. So each of these units, the orientation away, we're going to collect those as we go out, and then when we get to the final range where we lose connection, I'm going to turn around and then come back at the same altitude, and then we'll be able to capture the towards values as we come back. So we'll get this populated. Also at the far right here, I've got the actual full range from the receiver to the transmitter using the Pythagorean theorem. I got a formula in here to calculate at 100 feet. At that distance, I wanted to see exactly how far away that was. So you can see when we're at 200 feet away from me at 100 feet high, it's actually 223 feet away from me. So just so we got accurate distances. Trying to be as thorough as possible with this. All right, and then what you'll see from the second test, the only difference here is I'm dropping the receiver volts with my little simulated BEC. I'm going to drop that down from 7 volts to 5.1 volts, which is the voltage of my one of my ESCs that I was going to use for this test. I found that the voltage on the output was 5.1 volts to the receiver. So I wanted to do the comparison test to see how much difference it was between 7 volts and 5 volts, see if it made any difference on the range of the receiver. I think people will be interested in that. I was. Interesting results there as well. And then same antenna orientation. And then the third test, I was going to do 7 volts again with the antenna parallel. I decided not to bother with that one just because of the results from the other 2 tests, but I went right to test number 4 where I just kept it at 5.1 volts on the receiver BEC voltage, but with the antennas in parallel. And that's the final orientation you see here on my drone. Other 2 tabs here, I was going to repeat the test with a couple of Spektrum transmitters, but we'll do that for another video. In this one, I wanted to focus on the R88 because a lot of people are interested in that. It's a cheap receiver, but a lot of people are shying away from it because so many people are reporting problems with it. I'm keeping an open mind. Let's go through the test. We'll see the results, and then you can make your own call whether or not you think it's worth a try or not. So let's get into it. All right, here's my test setup. I've got a cell phone videoing the screen on the TX16S, so I can monitor the transmitter battery voltage, RSSI, pack voltage, RX voltage. You can see I've got the 7 volts for my first test, TRSS value. I'm not sure what that's worth, but I'm just going to record as many as I can. Got the drone. This is an SJRC F22S 4K. Laptop to record the spreadsheet information, and my transmitter for the drone with the phone. I'm going to do screen capture on this so you can see all the telemetry values for that, distance and height. And then here's my little test jig for the transmitter. Of course, like I mentioned, throughout these tests, we're going to be going from this orientation on the antenna to vertical, like that, and then to pointing straight out. I'm going to try those 3 different orientations for the antenna, and hopefully with all that, we'll be able to collect a lot of good data. So let me get set up. We'll get started.
Fly.
It's dropping down. I get up to 80 feet and it drops back down. I wonder if it's that I can't get any altitude. It's freaking it out. See if I can get it out of ways and just get some kind of information. Alright, I'm 700 feet. Let's yaw around. Alright, facing east now. Oh man, we got some serious wind coming up. I better get back. I was out there a long ways. I didn't get to where I'd be concerned. That's quite a distance. Oh man, I'm losing altitude. Uh-oh. It's going down. I'm taking a route so I can get back. Oh man. Not cool. Well, I got some data, but that just chewed it up. Holy crap. Alright. I'll have to go back and look at the footage. I couldn't really stop to document anything as I went. I see my lowest RSSI was 52. And I know I was over 750 feet away, so that's not bad. Hopefully I didn't wreck my drone. Alright, first try didn't go so well. We had a little bit of an incident on return. It didn't like carrying that big payload around. Plus I had a bunch of wind at the time. So here's what I've come up with for test number 2 to see if I can get it to go out and do the specific tests I want. So let's take a look. So rather than having that payload hanging off the bottom, which was interrupting the optical flow sensor, I think, plus it was like a big sail, and I had all that wind. So I've attached the receiver and the power supply and the battery Alright, I'm back at it for the third try. Hopefully third time's a charm here. So, yesterday I tried it. So first time I had that caddy thing, that was a disaster, but I had a ton of wind. Today is totally calm, so this would be in good shape. Yesterday I had the receiver and everything put here, but apparently the GPS is back here, and I couldn't get a GPS lock on the drone, so I couldn't take off. So now I have relocated everything. I've stuck the receiver on the side, my variable power supply on the other side, right next to it, with plenty of clearance on the bottom, not blocking any bottom sensors. The 2S battery I've got on the opposite side over here. Everything's stuck to the bottom, so I can plug it in and keep the wires out. The antennas I've got perpendicular. The one's going off to the side there, the other one's going straight back. I'm a little concerned about interference from the drone, which is why I was originally trying to put it on that little caddy below the drone so that wouldn't be susceptible to interference. But they are out in the open air. Hopefully that doesn't affect anything. We'll see. I've got to, just like yesterday, I'm going to head off that direction, just next to that house right there and that peak. So that's my target. I can get out there a couple of thousand feet or more if I need to. So I shouldn't only have to go over any houses. If I go right between those two houses there, just trying to avoid going over the top of houses and stuff and people. And I can still see it over in that area when I go out there. So going to go up to 100 feet. I'm going to go out. Every 200 feet I'm going to stop, and I'm going to reorient this antenna. I'm going to just move it like that, get my hand out of the way, see what the RSSI does. Then I'm going to do that, see what the RSSI does, put it back to that, go out another 200 feet, reorient it, and then I'll turn around and do the exact same thing coming back, so I get both orientations heading away from me and towards me. Hopefully with this new configuration of my test apparatus, we can get out there and do an accurate test. I've got a fully charged flight battery, transmitter's fully charged, so let's give this a shot. Hopefully we'll be in third time's a charm. Turn off our obstacle avoidance. Alright, we're going in okay. Stable. Go in. Take it up to 100 feet. It should just stop right at 100 feet.
Height limited.
Okay. Stopped at 110. I'm going to drop it down so we don't keep getting that message. Alright, there's our 100 feet. RSSI. Let's do our zero test here. Okay, so there's RSSI. You move the antenna up. Nope, the change. 71, 72. Go straight out. Now we're straight above it, so that actually orientation works. When we get out of ways, that forward orientation is not going to be as good. So with it straight above us, actually pointing straight out was actually the best. Okay, so let's rotate. Head right out over that. Let me turn on my crosshairs. Alright, I just want to go between those houses. Alright, let's go out 100 feet, or 200 feet. Alright, close enough. Alright. Now let's rotate the orientation up. I didn't notice any significant change. Forward. I'd get a drop when I touch it, but that's not, we're not going to use that value. Okay, go back up and over. Okay, now let's go out to 400 feet.
Height limited.
Okay. Antenna horizontal, antenna vertical, antenna pointed straight out.
Height limited.
Doesn't seem to make any difference on the antenna orientation of the transmitter. Okay, 600 feet, let's head out.
Height limited.
All right, there's our 600 feet. RSSI of 60. Now we're going straight up. 54, point it straight out. 52. Doesn't seem to make a huge difference. Okay. Now let's go out to 800 feet or until we lose our signal.
Height limited.
All right, there's 800 feet. I'm going to get this done quick. I'm kind of over that house. I don't really want to be. Okay, antenna vertical. Antenna forward. Did drop a little on that point. Okay, going back over horizontal. Okay, now we're heading towards 1,000 feet or signal loss. So far, the drone's performing awesome.
Height limited.
All right, there's 1,000 feet. RSSI still decent. Okay, antenna vertical. Antenna forward. A little bit of a drop, getting down in the mid 40s. Okay, now we're heading towards 1,200 feet or signal loss. Drone battery still good.
Height limited.
All right, there's our 1,200 feet. Still got decent RSSI, 1,200 feet away. Okay, antenna vertical. Antenna.
Height limited.
Okay, antenna pointed towards it. Oh, we just lost a signal when I pointed the antenna forward. Yeah, so you can see it definitely does not like the antenna pointing forward there. Let's go back vertical. Still not great. Let's go back to horizontal. Okay, we picked up a couple of bars, so that is showing that the antenna pointing off to the right horizontally is definitely better. Okay, let's head towards 1,400 feet or signal loss. Getting low.
Height limited. Height limited.
Okay, we're at 1,400 feet. I still have a signal. It is weak. Let's move the antenna vertical. Give it a minute. I think coming back it's going to be worse because my antenna is pointing backwards towards me. Okay, antenna pointed towards it. Okay, it's pretty definitive. Pointing the antenna towards your craft is definitely the worst. Pointing straight up. Recovered. Pointed straight to the right. A little bit better. Let me point it towards the left and see if that does anything. Actually pointing it towards the left picked me up a couple of bars. So left is better. Let's go back to the right. Left is better. let's use left on the way back. Okay, so let me keep going. There's 1,400 feet. Keep going straight out. Now I've got the antenna pointed to the left. I know that's kind of skews my numbers a little bit, but that just, I'm looking for the strongest orientation. And for some reason, this particular setup works better pointed to the left. Okay, there's
Height limited.
1,600 feet, almost. Okay, there's our 1,600
Height
feet.
limited.
Still got a signal. All right, this is working good. Still got signal. Let's go vertical. RF signal low. So yeah, we're down that low 40s.
Height limited.
Not liking it there. Now let's point it at it again. We know it's going to probably drop. Yep. So pointing the antenna straight at it definitely loses it. Okay, back up. Vertical. Got the signal back.
Height limited.
We got 45. We'll point it to the left. Jumped up to
Height
49 or
limited.
50. All right, let's point it to the right. Okay, it's definitely liking the left better. Okay, that's 1,620 feet. Let's go out a little bit more. Still got battery. $1,700 feet. It's getting low. Okay, we're at 1,778 feet, and our RF signal's low with the antenna to the left horizontal. Okay, 1,800 feet. That's where I lost it. Okay, 1,800 feet at 100 feet altitude. That seems to be the bad spot. All right, I'm going to rotate around. All right, now I'm pointing back towards me. I do not have good signal. Let's point the antenna up. Interesting. So pointing back towards me, I point the antenna straight up and I got a much stronger signal. Let's go point straight out. Huh. So pointing towards me, the antenna pointing straight out actually works better than when it was facing away. Now I'm back vertical. I got 3 bars, 51 RSSI. That's a lot better. Point it to the left. Let's try to the right. Point it back to the left. Back vertical. Interesting. So when it's facing me with the antennas facing away, it actually works better with the antenna pointing straight up or even forward. Fascinating. Okay, I'm going back to the left. Let's start heading back. I need to come at each 200 feet, just like I did. Try the different orientations, try to get a thorough test. Looking for 1,600 feet. All right, there's 1,600, pointing to the left. Got a pretty good RSSI. Vertical. Not much change, better if anything. Pointing straight out. Bit of a drop. Still got a signal though. Got a low signal. Okay, up to the right. 50. Okay, back to the left. Okay, heading for 1,400 feet. Oops, overshot. Let's back up. All right, here's my 1400 feet. Antenna to the left, RSSI. Antenna vertical. Antenna straight out.
Telemetry lost.
Hmm.
RF signal critical. Telemetry recovered.
Interesting. Could be because I'm going behind those power lines. Okay, antenna to the right. Antenna to the left. Okay, heading for 1200 feet. All right, that's antenna to the left. Antenna vertical. Antenna straight out. Antenna to the right. Antenna back to the left. Okay, let's go for 1000 feet. Or excuse me, yeah, 1000 feet. All right, we're kind of over that guy's house, so let's.
Height limited.
All right, antenna to the left. Antenna vertical. Antenna to the right. Antenna straight out. We're close enough that that's not really, we're not really losing signal much anymore. Okay, antenna back to the left. Come back to 800 feet. Battery at 52%. All right, there's
Height limited.
800 feet-ish. All right, antenna to
Height
the left.
limited.
Antenna vertical. No real change.
Height limited.
Antenna straight out. A little bit of a drop. Antenna to the right. 60. Antenna to the left, okay? Coming back to 600 feet. All right. Closer to 600. All right, antenna to the left. Antenna straight up. No change. Antenna straight out. A little bit of a drop. Antenna to the right. Antenna to the left. All right, there's 600. Now we're coming back to 400. Oops. All right, that's antenna to the left. Antenna straight up. Antenna straight out. Antenna to the right. Antenna back to the left. All right, come back to 200 feet. All right. Okay, that's antenna to the left, antenna straight up, antenna straight out, antenna to the right. All right, let's get it straight overhead in that same orientation. Oh, we got a big bird. Alright, it's close enough to 0. Alright, that's the antenna to the right. Oops, antenna to the left. Antenna up. Antenna straight out, which I'm assuming will pick it up some because we're straight up. Yeah, not bad. Kind of jumpy. Okay, antenna to the right. And then back to the left. Okay. Still got 39% battery. I wonder if we got enough to drop the transmitter. So we still got 7 volts on the receiver battery. I'm going to have to charge up another battery. That worked great, finally. That's exciting. Awesome. We finally got a good solid test. Now I want to drop the receiver battery back down to 5, and let's check it again. That went super awesome. All right, now same test, but I want to be at 5.1 volts. You can see my RX battery coming down. I want to see how much different the range is at a more typical ESC voltage. All right, there's 5.1. What do I got? I got 37% battery. I think I'm just going to go straight out and back. I'm going to leave the antenna in the left orientation because it's clearly the best orientation, and we know that it's worse when you go straight up or point it straight out depending on how far away you are. So
Fly.
alright, I just want to go up to 100 feet. I want to go straight out and straight back, and we'll just watch the RSSI as we go. Alright, I don't want to waste any time because we only got 34% battery on the drone. Alright, there's our 100 feet. Alright, let's go for it. I might kind of pause at each. There's 200 feet,
Height limited.
240 feet. The drone's kind of crabbing one way. All right, there's 400 feet. Let's get it out to 600 feet at least. All right, there's 600.
Height limited.
Let's keep going so we're not looking at this guy's house. $800 feet. Still got a pretty good RSSI.
Height limited.
I can't remember top of my head how far we got.
Height limited.
Still got a good signal. There's 1,200 feet.
Height limited.
14. Let's stop at 1,400 feet. All right.
Height limited.
So 1,400 feet. We got a 49 RSSI. It's a little low. I can't remember where we were last time. Let's just do the antenna test while we're here. Straight up. Actually improved. Straight forward. Little sketchy. Okay, to the right. Back to the left.
Height limited.
Okay, let's keep going out. See if we can get out to 1,600 feet. Okay, they're 1600 feet.
Height limited.
RSSI is getting a little low. Okay, keep going. $1,700,
Height limited.
$1,800, $1,900.
Alert signal low.
Still got a signal, but it got low. Let's go straight up with the antenna. Dropped it.
Telemetry lost.
Height limited.
Point it forward. Still dropped. To the right. Nothing. Back to
Height
the left.
limited.
All right, well, you don't have a...
Alert signal critical.
Height limited.
Oh, we got the signal back. We're at 1,900 feet. Let's go a little bit further. 1950, 2,000 feet.
Height limited.
Alert signal critical.
Yeah, we're right at the limit. 2,000 feet seems to be about it. Okay, so let me flip it around. Okay, now I'm facing back. Still at 100 feet. Let's start heading back. Got a signal. at
Return
2,000 feet.
home.
Oh. All right, it's returning to home because my battery's low. Hopefully it'll make it all the way back. %, battery. It's doing auto return to home, so we'll just watch the value as we come back. Can't control it anymore. Well, I'll be honest, I'm issues with the range on this thing. This is a pretty successful test. That's a long range. I would never fly an RC plane out that far because I could barely see it. If anything, it'd have to be a pretty big RC plane. I mean, the drone was barely a dot out there at that range. All right, we're getting close. 300 feet. Now we're gonna make it easy. Nice. All right. Well, I think this has been a fantastic test.
Drone low voltage.
Awesome. Made it back. Got a good successful test at 2 ESC voltages, or receiver voltages. Alright, so I'm going to grab another battery. I'm going to try to move those antennas real quick. Alright, I don't have a full battery, so I'm just going to go straight out and straight back with these things parallel this time. If it results in anything interesting, I'm going to do another one. Here's how I did with the antennas. I got them both coming out right by each other. Antennas are right parallel, straight out the back. Alright, let's do this.
Fly.
Alright, reset that to keep it at 100 feet. Alright, let's get up. Oh, you know what? Let's reset the telemetry real quick. Alright, telemetry reset. Still recording. Alright, let's take her up to 100 feet.
Height limited.
Got a bit of a wind coming up. Hopefully that's
Height
not
limited.
gonna cause a problem. Okay. Yay. Alright. Let's head off over towards our target. Straight out. I'll try to pause at each foot range so that we'll go out to 200 feet and take a look Just briefly let it settle. All right, there's 200 feet. RSSI looks great. Okay, we'll go out to 400 feet. RSSI looks great. Oh, battery's at 21%. That's not good. RSSI looks great. I'm not going to go too far out because it's going to turn around and come home in a minute, but let's just keep going. 800 feet. Those antennas in parallel don't seem to be making a big difference. This thing's going to turn around and come back any second now, but let's get out as far as we can before the battery dies. 1,000 feet. RSSI still looks great. $1,200 feet. RSSI is not complaining, but maybe on the return run it will because both of them are pointed back towards us. 1,400 feet. Starting to get a little low on the RSSI, jumping around a little. 1,600 feet. 1,700 feet. RSSI still looks pretty good, actually. Okay, now it's getting low. I'm at 1,800 feet.
Return home.
All right, it's coming home now. Now it's turned around. RSSI still looks pretty good. It's coming back. 18%. Hopefully it makes it all the way. It's kind of a low battery to start with. Come on, buddy. Coming back. The RSSI is looking fine. I'm not seeing an issue with those antennas being parallel like that. That's very interesting. Parallel receiver antennas does not seem to be causing any sort of an issue. I couldn't quite get out as far just because my drone battery's low. We'll have to charge up another battery and take it back out, see if I can get all the way out to like 2,000 feet like I did, but where were we at? 1,800 feet? So we're fine. And we made it back. Nice.
Height limited.
Is it not coming home again?
Down. Return home.
I would say we got some excellent tests. I'm actually surprised that those parallel antennas didn't seem to cause any issues. We'll go through and frame by frame and enter all this data into our spreadsheet and see where we're at. But I would say the receiver, or excuse me, I would say the transmitter antenna orientation makes a way bigger difference than the antenna orientation on the receiver. That was pretty significant, but it's not always consistent. So it depends on where you're at, how far away it is. So a lot of variables to consider. let's crunch the numbers. Well, after many days of testing and trying to get a good system down to do these tests, many hours of editing. If any of you guys have done any editing, you know, with 3 different camera angles and different audio tracks, you know, and my computer's not the fastest. This has taken me a long time to get this edited together. So if you've stuck it out, I appreciate it. I know this is a long video, but there's a lot of good information here. You know, if you didn't want to sit through all the testing, you can, you know, maybe you just skipped all that and you're right here to the conclusion to look at the results, and that's fine. But there is some pretty useful information that we found out going through all these tests and trying different antenna orientations and stuff. I think, you know, everybody talks a lot when we're all chatting on the internet and stuff about, you know, which way to put the antennas, and, you know, we all kind of know the better ways to do it. But to actually have specific data collected to show the results of moving your antenna in different orientations and, you know, at different distances, it was pretty fascinating, I think. I think I got some useful information. And this has been kind of fun to do this. This is a lot of data. So let's cut right to it. You guys have sat around long enough. We're like almost an hour into this right now. So just for curiosity, the very first test I did with that caddy hanging off the bottom that ended up disastrous, we kind of crashed it at the end. This is the data that I collected on that little short flight. Made it out to a distance of 767 feet. Never really had any issues with the RSSI. You know, I really anything 45 to 50 is kind of getting on the low end. You know, low 40s is where you're getting ready to lose a connection. 50 or higher, I'm totally feel comfortable flying as long as I get a RSSI of 50 or higher, and we're way over that on almost all of these tests. So that first test out to 760 feet was totally fine. Where actually in the altitude was much lower. I couldn't get the altitude I was hoping for. I wanted 100 feet. I just couldn't do it because with that caddy thing on there and the wind, it was wrecking it. I couldn't do anything. So anyway, I don't want to spend a lot of time on this, but RSSI was great. And, you know, as we go through this, line of sight in my RC planes, I don't think I ever fly more than maybe 500-600 feet away would be a stretch. Generally, I think I'm within about 400 feet probably or less is where I fly line of sight with my RC plane. So all of these tests, I found nothing that would lead me to be apprehensive about this receiver. I'm sorry, but everybody's going to argue with me, but you know, based on my test, and this is all I can go by, these are looking pretty good. Okay, so let's get into the first real test. So this is the first time we got it out, and we collected a lot of data on that flight. Everything in the green was basically the best signal, or tied for the best signal as we went through everything. Now, we got out to 1,400, 1,600 feet. I probably wouldn't feel safe. We had a signal clear out to 1,800 feet, or just shy of 1,800 feet. I wouldn't fly out that far. I can't see the plane anyway that far away, you know, to really know orientation on a standard line-of-sight airplane. That's a long ways out. So, I mean, unless you're doing some kind of FPV stuff, you're not going to get that far away. Because if you're that far away, something else is going wrong because you're heading, you know, you're not going to know where you're going. Signals were good. As you can see, as I get further away, I did try the left orientation, and in almost all cases, the left orientation worked better for some reason. I don't know the technical reason why, but facing that antenna to the left, it definitely made a big difference, and in most cases, it was a higher RSSI number. I don't know why. If you know why, put it in the comments below. That'll be interesting. There's some technical reason why that would be. So we tried right and left. Once we tried that and realized the left was better, we made it up to 1,800 feet before, you know, we really lost any signal. I don't think it's a surprise to anybody, but pointing the antenna directly at the airplane, a lot of people just immediately go to that. You know, new pilots generally, that's their first go-to is to point the antenna right at the airplane, thinking that that's going to shoot a beam right at it, and it's actually the opposite. As you can see here, you know, that was by far the worst. You know, other than a few specific positions of the airplane and the receiver, pointing the antenna towards it was by far the worst, in almost all cases. Pretty fascinating information. It doesn't really show it on this. If you watch the video and, kind of go frame by frame as you get, what you're going to notice is even when these RSSI numbers that you see here are decent, sometimes the vertical antenna, but always the pointed away antenna, pointing it right at the airplane. These values, I had to come up with a value to use, but they were very jumpy. They were very rarely were they stable numbers. Most of these other ones, with the horizontal left or right, were much more solid fixed number. They weren't jumping around so much. Then we jump to test number 2, where we dropped the receiver volts down to 5.1 volts. The battery's a little bit low, so I did not go to, take all the time to collect all this other information. I think after that first test, it's pretty definitive that the horizontal left-facing antenna was the best. So I kept it at that. I did, once I got out there, I tried a couple of different orientations on a couple of these positions, as you'll see here at 1,400 feet. We tried to go right and left. Left was still better. And then also at 1,932 feet, we tried that, and left was better. And then we lost connection on both of them at a couple thousand feet. That's way out there. And then a couple different locations, I tried the pointing away antenna, and as expected, they were not good. Comparing these numbers to the numbers on test 1, we're up in the, mid 60s, high 50s, most of that. We're pretty much, it was confirmed to me that the voltage, between 5.1 and 7 volts didn't make any difference, or at least no significant difference. So higher BEC voltage isn't necessarily, at least with this receiver, isn't necessarily going to give you any better signal strength. So that was interesting, because I thought, with that big of a voltage range that the receiver will expect, and maybe if we bumped it up to the 8.4 volts that its maximum capability, maybe it would go farther. I don't know, but based on this, I'm totally comfortable flying it at 5.1 volts, which was what my ESC would output. And then we didn't do anything for test 3, and then test 4, where we moved the antennas parallel. This one was a big shocker for me. Almost no detriment to the signal strength whatsoever from my test. A lot of people always say that, you crash your plane, make sure the antennas are perpendicular and not parallel. Based on this test, the parallel antenna was just as good, if not better in some cases. These numbers are fantastic, so I would not have reservations about putting my antennas in parallel in my airplane. I don't think it's going to be a big deal. In most of the foamy airplanes, you're probably going to have less interference than you would have with this receiver strapped to a drone like I had. There's all kinds of interference. It's got its own transmitters, ESCs, GPS, fairly powerful transmitter and receiver built into the thing with telemetry. I don't see, this one's a shocker to me. I thought parallel was going to be worse, but parallel antenna doesn't seem to be a problem. By far, the biggest difference was moving the transmitter antenna orientation. So if you were on the fence about that, it seems pretty definitively clear to me in almost all applications, horizontal, left or right, but particularly to the left in this case. I don't know why, but definitely seems to be the best way to do it. If you've stuck it out all this time, I appreciate you watching. If you have any comments, put them in the comments below. Let's crunch some numbers. I think this is pretty fascinating. Take this for what it's worth. I'm comfortable flying with this receiver. If you're not, then don't. It's a cheap receiver. Some people say you get what you pay for. I don't know. I've never really been a believer of that. I think that there's a lot of good products out there that are just cost effective. I have no reservations flying with this receiver now based on these tests. So I'm going to put these in my airplanes. I'm going to go fly it. Something happens differently, I'll take that as it comes. But very fascinating. And even, the different knowledge now of pointing the antenna different direction on the transmitter and how much of a difference that makes, I think is going to make useful information for any receiver you're going to use. I may follow this up with some tests on a few other receivers that I have. Now that I've got the test platform on my drone, I think it's a pretty cool test. I'm going to do a couple of my Spektrum receivers. If you think of any tests you want me to try to replicate, let me know the details of what you want me to try, and I can do it, different altitudes, distances, orientations, something. If you think there's something useful, I can give it a shot. So put it in the comments below. I appreciate it. And again, thanks for sticking it out. This is a long video. It's been a ton of work to put this together. I spent a lot of hours editing this video to put it all together with all these different camera angles and spreadsheets, and it's It's a lot of data and a lot of numbers to crunch and a lot of time and effort. So I appreciate you sticking it out. Hope this was useful. If it was, please like and subscribe. Put your comments below. There's going to be some affiliate links below for some of the products that I use. If you can, if you're interested, click on the links. It helps the channel out. It doesn't cost you anything. And thanks. Take care.